So today we're going to focus on the topic of AVIcode and how to go about diagnosing application problems. Before we jump into that, my name is Chris Childers. I also have on the stage Sean Gibbs. We both came over from the AVIcode acquisition. We spent the last 5 years, I'd say, respectively, focusing on APM solutions. So we want to share with you some of our knowledge and experience and how that relates to AVIcode today. Before I jump into the conversation, I want to ask a few questions. Who in the room knows about AVIcode, has seen a session, okay, I'd say about 2/3. And then as far as who we have role-wise in the group, how many IT pros in the audience? Okay. How about developers? Wow, even split. Well, this will be fun. Great. How many, just one last question, how many people have actually tried or has AVIcode installed in some sort of capacity? Okay, a few of you. Excellent. So some of this might be repetitive, but hopefully we'll cover some new topics for you. So what I want to do is, the goals today is really to give you some strategies for how you can go about analyzing your applications with AVIcode, and really understand how to diagnose and what the information AVIcode is collecting and how you can use it to identify root cause situations in your application. We're going to end the conversation today focusing on the reporting and analytics that AVIcode provides and how you can use that for longer term trending and analysis. So we're going to start just with an overview. So forgive me if this is repetitive for some of you, but for those who haven't been exposed to AVIcode, I want to make sure everyone has a good level set on what really is the problem domain we're focusing in on. We'll spend most of our time talking about these data analysis strategies and Q&A along the way. I will mention that we have a pretty small group today, so please stop us along the way if you have questions. I think that's a nicer way to go when we have a group like this, and we'd be happy to answer as we go along. So let's talk about really what is the problem that we're dealing with here. So as we all know, we have these increasingly complex application environments. So we have these multi-tier environments. We have end-user endpoints, whether they are browser front ends or clients. We have distributed application tiers. We might have an enterprise service bus. We have database servers in the background. What we often find is that we have a lot of knowledge, I'll say, organizationally, at least in working with customers on, how's the network performing? Is the OS up or down? Is IIS up or down? Where we tend to lose visibility is up in that application tier. Typical strategies that are in play today is instrumentation. So we have a custom application for the developers in the room. I'm sure you're quite familiar with this. We write code, and we put it in, maybe we write out to the event log or a database. Obviously, that is non-core code that we're writing for our application, and often it becomes part of the application that we have to maintain and grow over time. So when we're managing application and production environments, the question always is, how do we even know that we have a problem? Right? Typically, it's coming from the end user. Sometimes we don't know if somebody doesn't raise their hand, or maybe we are finding something in the event log that tips us off. Secondly, how do we go about isolating that problem? How do we isolate it from the system stack, from the OS, from the host, and how do we isolate it within the application itself? Right? Is it happening on the web front end? Is it happening in the services tier, et cetera? Once we've gone through that process, then the question becomes, how do we actually go about diagnosing? And this is where we typically have a hard time because we don't often have a lot of criteria to go with, right? So we make a lot of guesses as to why a certain situation is happening in a production environment. And of course, all this is quite costly within an organization. Now, when we talk about application management, it tends to be a bit different, application management monitoring, it tends to be a bit different than your typical system management where it's really an IT-focused solution. When we talk application management, we have different stakeholders that are involved in the process, right? We have the app owner, admittedly a very nebulous role, but title-wise it might change in an organization. Usually there is somebody that takes ownership of the application, and of course their focus is time to resolution, uptime, reliability, customer satisfaction. We have Dev QA that obviously in the early dev cycles out through QA, we're focused on making sure that we have an application that's of high quality and reliability before we push it out into production. And then, of course, oftentimes we're dealing with level 3 type support issues, bugs that are coming back, and in those cases need to have enough diagnostic information to triage those issues, right? And then we have the operations team, who in many cases is ultimately responsible for making sure that application is running. And it's the operations team that's the front line of defense when there's something going wrong to pull all the information together. So what does today's world look like? As I mentioned at the beginning, it typically is an inconsistent approach to application monitoring. It is instrumentation, it's varying management strategies to get that visibility that we need. You know, Xbox Live is an internal customer that uses AVIcode quite extensively. So if you're out gaming using Xbox Live, we're actually monitoring it behind the scenes. And the gentleman who's driving that initiative had a really interesting comment in that he said, up until we were using AVIcode, we had no common language between IT and ops. And that really has to do with this inconsistent approach and lack of visibility, right? It drives that poor communication. Anyone seen this, right? Luckily, in this case, we actually have a user that says something's going wrong. In many cases, we don't, you know. But hopefully, we find out that we're having a problem, and then we get this ping-pong effect between IT and dev. Okay? And it really is because of this inconsistency. So this is where AVIcode plays. So AVIcode focuses on addressing these for the .NET platform and provides visibility across this application stack. So if we're dealing with web-based applications, as an example, we have end-user monitoring solution. So we dynamically instrument the response going down to the browser with JavaScript. Sean will get into this in a little bit more detail for you, so that we can have visibility to the performance of, you know, total page request time at the end-user endpoint. And we can correlate that through the transactional tiers of the application, getting to that isolation, right? So we can monitor also the server side of the application, or the various distributed components, and tie that together so that we have this visibility end-to-end in the application tier. And we can also tie that together with what's going on the host, so that you can determine this relationship of, you know, what was the application behavior and what was the host behavior, and is there some relationships there? And of course, just like for those that are familiar with Operations Manager as an example that has a transactional database, right? We have transactional alerting and eventing. We also have a reporting and analysis piece that we could do longer-term trending and analysis, and we'll spend some time diving into that later on in the conversation. So for those that haven't been exposed, some key features about AVIcode. First thing to note is from day one, AVIcode has been designed as a production monitoring solution. In many cases, customers are using this, of course, in QA as well as production. QA gives you the obvious advantage of being able to get kind of an inside-out insight to the performance of your application and help determine, you know, performance or failures happening in your application before you push it out. Obviously, that's going to improve your quality. There is no code modification required. So what happens is we're an agent-based solution. The agent gets deployed to the target host. So let's say IS server if you're hosting a web application. And through a configuration, through the rules that you define that describe how you want to monitor that application, we will dynamically at runtime hook into the application and monitor the application. And again, as I've mentioned, for web-based applications, we can give an end-to-end view of that all the way from browser endpoint through without having to deploy any type of agent technology down to the browser. I always say there's really three core things that AVIcode is collecting. We're collecting statistical information about application overall performance, things like average request time, volume of requests coming into the application. We're collecting event information and diagnostic information when, as you've described it, the performance of the application exceeds certain boundaries. So if a transaction is running slowly, you can collect that diagnostic information, as well as application failures. Everyone's seen that nasty call stack, oops, had a problem kind of page. Okay? And the key to all of this is the level of detail that we're able to collect. And the purpose of this discussion today is to get into some of that detail so that you can understand and take that back with you. And for those using Operations Manager, this all hooks into Operations Manager through a series of management packs. So there is a standalone AVIcode infrastructure that has its own web-based console that you'll see in a moment. We have our own agent that is specifically designed to hook into the .NET runtime. And all this can be integrated into Operations Manager through a series of management packs. So the goal is really to simplify this process of being able to know that we're having a problem, isolate and diagnose, and have that common language. So even though many times when you're looking at application problems, and Sean's going to introduce you to some, if you're on the IT side, you're going to say, hey, this isn't for me to deal with. And in that case, you need to hand it over or escalate it to the appropriate team. And in other cases, you will deal with it if it's a change management type issue. But the key to this is that you do have that common language and common set of knowledge to work with. So let's talk about data analysis and start to jump into this. So there's really two ways that we can do data analysis with AVIcode. The first is looking at the real-time events and statistics. So we can do this either through Operations Manager, or we can do this through the standalone console. And really, this is to focus on incident and problem management, right? Looking at the real-time events coming in, understanding the nature of the problem, and understanding which group needs to take ownership of that. And then there's trend analysis and reporting, where we want to step back and look at this information from a variety of lenses. And the reason for that is we have various stakeholders. We may want to say from an IT perspective, let's look at capacity planning, right? Let's see what's the load on the application, maybe over the hourly profile or the weekly profile of the week, and look at that in relation to CPU and memory consumption. Is there a relationship there? You know, when load goes up or doubles, does CPU go to 100%? Do we need to add more hardware? The application development or application support team may want to look at it from a problem management perspective, right? How do I isolate and figure out that 80-20, right? Is there 20% of the problems occurring that are, or are there 20% of the things causing 80% of the problem that we can focus in on and get a big bang for our buck? Easy wins. And typically, for those that haven't used AVIcode to date, you will find that very quickly. Once you implement it and start monitoring, you'll find quick wins. And I'll show you some examples. So just to tie it all together, how do you know that you have a problem? Again, you have several ways using AVIcode, either through the Operations Manager management packs, where you can have real-time alerting. You can have health state changes. You know, this application has gone red. You know, you're in a failure state. Or you can use the AVIcode web console to look at events as they come in real time, and we'll review this in just a moment. There's really two types of alerts in Operations Manager. So we have your typical events and alerts that are coming in. We also have alerts based on performance counters. So instead of just diagnostic events, we have performance counters like average request time, where operationally you can say, I want to be alerted when the average for all my user requests exceeds 10 seconds. And then we have monitors that can change the health state. Again, maybe your rule internally is, we expect the performance of this application to be under 10 seconds. And you can set up monitors that change the health state of the app accordingly. Did I still? Looks like we're a little out of order here. So then how do we isolate the problem? I think we've covered this. We can isolate the problem either using AVIcode to understand what's happening at the application tier, or for those that are using Operations Manager or frankly any system management tool, monitoring the application is only one half of the coin, right? There's all the infrastructure that goes under that. So you're going to marry this information up. Many times I see situations where people say, hey, can AVIcode help me understand this? And maybe they're fringe type of scenarios. And my answer will be, even if we don't pinpoint it for you, we might be able to rule out that it's the application problem, which is a big step forward if you're trying to analyze and diagnose, right? We can say, you know what, it's not an app problem, it's a system level problem. Go focus your energy there. And then you're going to turn to something like Operations Manager to continue the isolation process. And how do we diagnose? This is what AVIcode does very, very well. We collect deep level information about the app so that you can analyze and understand the nature of that app and then triage and ultimately fix it. So I'm going to turn this over to Sean Gibbs, who's going to talk you through about how you can do real-time analysis of applications and take you through a series of examples.
Great. Thanks, Chris. So I want to start off by a couple of comments and a couple of questions. So just a few comments about what Chris said, and you know, apologize for those who have installed, used, and heard those things before, but it does help kind of make sure we set the stage and everybody comes in and knows exactly what's going on with what we're going to be presenting today. It's really important that we don't feel like we walked into the middle of a movie, right? I do want to ask a question, though, because we've got the perfect audience for it, and I don't always get this audience where I get such a nice mix. Does anybody know how many developers it takes to change a light bulb? Don't stop me if you've heard this before. None. It's a hardware problem. Nobody gets that? Okay, well. Yeah, I don't get credit for too much. But so Chris has talked about a few things that are really some of the stages and steps that we go through, right? Understanding when there's problems. Do we understand it because somebody called? Do we get alerted because a mom's telling us or operations manager is telling us, or somewhere along the line we're finding out? And then we have to kind of triage that and understand what's the severity of that. And usually we're given the severity of it by who called. Was it the boss? Was it a bunch of people? Was operations manager telling me it's affecting all my servers? So we understand the severity a little bit, right? But what is it that helped us get to that point when we're using AVIcode? Well, it's a series of events that are collected and timings that are being performed on the applications that get us to that point. These events fall into some basic categories or basic event types. We're looking at application errors in the code, things that developers are very familiar with. They're called exceptions because they should be the exception to the rule. And we're looking at those. We're looking at the performance of the code. What are some of the interesting things that the code's doing and timing that? And we're collecting those when they step outside of what somebody has said is the perfect service level or an optimal service level, what you want to collect data on. And then we're looking at some other things that are somewhat incidental that you may already have access to, but we're just bringing those over and correlating them like event logs and performance counters. Some of the different types of analysis we do allows us to put these failures into different categories. So we look at an exception, which developers probably are doing. They're looking at an exception in their code already, but we're taking that exception and we're saying, why did it happen? We have some basic understandings that if it happened because you couldn't connect to SQL, then it's a connectivity issue, right? And if you got a connectivity issue in production, that's a change management issue, more so than a developer issue, even though it's an exception in the code. So we're telling you that. We're analyzing that data and we're saying this is due to connectivity. And we're giving that to you in such a format to where we can alert the right people. So it's just not alerting, it's triaging, and it's giving the right information. What database were you trying to connect and what security were you trying to use when you failed? So that's the type of information we give. Same with the security credentials we look at when you're trying to connect to that database. Did you not have insert permissions? So we analyze that information. When we look at a performance event, we look at a performance event across all the tiers of the application. So if we're monitoring all the tiers of the application, we can tell you at each level where those problems were happening. So if you're reliant on a back-end system like a SQL database or some other communication to a text file or something like that, we can tell you that that's the final root cause, right? Or you're waiting on another application to respond. And we can correlate all those together so that when you get into that deep dive, you'll be able to have the right conversation with the right people responsible for those systems. When we're looking at a client-side event, that's typically what's going on in the browser. We're monitoring that HTML, and we're saying that this took X amount of milliseconds to respond, and here's how that breaks down. We take you through where the server was that was responding to that request. We take you what was the request information. Query strings, the user, credentials, anything like that. We understand from a browser's point of view what was the information or what we call the payload. What was the images and context sent down with it. For example, CSS sheets and HTML and JavaScript files, anything else that's sent. What's the size of that? Could that be impacting it? When we look at a server-side performance event, we're breaking those down to what's interesting. So what took X amount of milliseconds inside that server-side response? So we're looking at an entry point, and we're saying that entry point stepped outside based on this server responding to it. This call was waiting on these slowest resources, or what we would consider to be the root causes in that top section called the slowest nodes. And then we have the execution tree of events down in the bottom, where we're breaking down the execution time for the things we considered important. That's how we're configured to monitor. That's how we collect that detail. Again, application failures can be both server-side and client-side, just like the performance problems. So we're looking at things like JavaScript application failures in the browser. We really haven't had visibility into those in the past, other than maybe an end user calling, taking a screenshot, or we were using the application, or somebody local was using it and told us that there was a problem. We're actually capturing those metrics and reporting that back. We're looking at what's going on in the server when those exceptions are taking place and trying to gather as much detail as we can without causing any impact to the application responding to other users. When you're looking at a client-side JavaScript failure, we'll even go as far as in the detail or the diagnostics information, give you the amount of detail we can around the JavaScript itself. Slightly dependent on the browsers that the JavaScript failure was thrown in, but we can bring back exactly what was the function you were using in the JavaScript and parameters and detail around that. Server-side failures include similar information, inner, outer exceptions. So it's all captured into one instance, one event. If I haven't already said it, we call these structured events. Because one of the things you'll notice when we capture these things, we're actually giving you an aspect, giving you a reason why it's happening, give you a limited stack trace or a limited execution tree. So we're structuring it to make it more meaningful and helpful in a quick view. And we'll go through some of these examples. And then when we capture that event, and this is probably one of the lesser known details, but more interesting details, because it was one of the things that not everybody has ever had access to in the past at the time of a problem. What I mean is, if I had a customer call and tell me, application's slow, some of the things that I started off with were questions around, what do you mean by slow? What's slow? What was the timing? What were you doing? And we had to gather some data. And then we had to, once we got that data, we had to start analyzing the systems, analyzing what was the load, trying to get more information. In the worst possible case, we had to try to recreate it. But right now, what we're gathering are these troubleshooting performance counters, and I think that they're pretty significant when you're looking at things like application response time being slow. What was the server doing at that moment in time? So these performance counters include the things like performance of the server, through CPU utilization. So I can overlay that into this troubleshooting mechanism. I can look at what was the CPU of the application that was running slow. Maybe the server was being used by something else. This application wasn't using much CPU at all. It was just waiting. So we'll be able to correlate that information. We haven't had access to that all the time. So even now I know what they meant when they said slow because I captured the event around that. But I also know what was the state of the systems and the application at that time. So we'll go into an example and actually show you what that looks like. One of the first things that Chris talked about was the alerting stage. Some of the data and details that we capture help Operations Manager do that for you. So we gather this information, we bring it over. Operations Manager is looking at average response time to set that alert, looking at individual incidents to set alerts, and then that information is gathered and stored inside Operations Manager. So when I look at an event or an alert that comes in, I'm going to get some of the same details I just showed you, but these are now in Operations Manager. Put my glasses on. There we go. Now I can see. That helps. So you go into the alert context, what actually created the alert, and you'll see that these look just like some of the events we showed you. So it's the context, the stack trace, the information that was included. So real quickly, I'm going to walk through a very boring event, but it's probably worth doing just so we can see what's happening that causes one of these problems. So I'm going to log in as a user into an application. One of the main reasons I'm doing that is so we'll actually be able to see that this captures that user's information. You can see that it throws an exception that in this case we didn't show a friendly page, meaning the developer didn't kind of redirect to something nice and pretty. It really doesn't matter what happens. AVIcode's collecting that. Now you might get one incident, one alert, and that helps you triage exactly what's going on. And in this scenario, we're actually looking at it would take a number of those in a given time period to put the application in an unhealthy mode. I don't want to be alerted when it's one problem, when it's one user typed in one thing in the text box to cause it to happen. So we still need that data because that data is important to analyze the application further down the road. Maybe during the next fix they can see what they can do about that. If you look back in the SE Viewer, and this is our console, and those of you who attended some of the earlier sessions have seen how these components break down, but this is the method in which you would review these events. Typical scenario, this is where we would go to start analyzing a problem. Whether development or IT pros, really doesn't matter because this collects individual incidents. So now I see that those two failures where we saw the error page are copied over into the SE Viewer as application failures. And you can see under aspect, it's given that category, that aspect. That's pretty important because that's your first stage of triage when you're looking at the events. I know which server threw those failures. The source of the failures is the application name. And with the red circle with the white X, I also know that those failures were unhandled, meaning that the developers didn't put them into some logic to deal with them or log them or do anything with them. So that alone tells me the criticality of those events. They impacted an individual incident or individual user fairly severely, meaning ending their ability to continue. So you can simply drill into those, but if it, again, was one incident, we probably don't care about it. So what we need to do is to start realizing how many times does this happen? Is it really a concern? It happened a couple times we saw, but let's actually look in similar events. So similar events now, it lets me filter in a time period and look at this problem as a unique stack or a unique event and how often it's happened. So 11 times in this time period, this show order function the developers wrote failed with a null reference exception. So that might not be severe enough in a very large application to do something about it. But it also could be one of those low-hanging fruits that a developer can say, well, a couple of clicks, I can fix that. They can drill right into the information, and they can see where it is in the code and what to do with it and recreate it because they've got parameters to look at. So they can go in and look at exactly what the details were that caused that problem. Other ways that we can look at that in this similar events view allow us to look at the action. Because when a customer calls or when a concern comes in, they're not going to tell us I was in the cart page and it failed with a null reference exception or something like that. They're just going to call and complain and say, I tried to buy something. So now I'm going to look at the action in a web application. These are going to break down to which pages they were actually viewing. So how many times did this cart page actually have incidents collected? Performance or failures. That's basically the phone calls that would be coming in, right? And then maybe even the exception class. Developers can look up how many times am I receiving that null reference exception. We as developers always love those. Those are fun ones to work on, especially when they get out into production. Now, when you look at this many exceptions in a given time period, that's not that bad. That's maybe not enough to go work on. What we can do is we can take all the information that we're collecting and look at it a little bit different. So I can see here, for example, the number of events I've collected in a given time period. And I'm just going to change the date. It defaults to the last 2 weeks. I'm going to change it to everything I've ever collected, keeping in mind that we groom this database fairly aggressively. So now I have 4,300 incidents that I've collected inside the SE viewer. And the way I like to look at it is, well, that's not problems. That's not 4,300 problems. If I wanted to diagnose my most current, top-of-the-line incidents and issues, I'm going to group them by problem. So I'm taking 4,300 incidents down to 133 unique records. Now I can take those unique records, those unique problems, 133 problems, and I can say how many of them really is the interesting piece. So when I sort them by count, the number of them that are happening, I can see that registration is my biggest problem, and it's a performance problem. People are registering on the site, and that's slow. So you know where to go, what to tackle. When you're looking at these performance events, again, let me drill into one of these. Some of the things that would be interesting is why is it slow, right? Well, this particular one, it's slow because the 2 SQL calls are actually collected as being slower than normal. So these stored procedures, if I expand those out, you'll see what the stored procedure name is, the database we were talking to, and the parameters that went with it. How many times were these stored procedures issues? Well, let's go to similar events. I've got it grouped by problem. Now I'm going to actually group it by heaviest resource. Let's see if those resources come up. No. Only one time. So I'm not really too concerned about that. Yes, have a question?
Well, I was looking at the data you're showing there. Your procedure calls for like 200 and some odd milliseconds. And the performance thing is, how do those two procedures, how did you use those two procedures?
Good question. So what we have is the ability to configure what we're collecting inside of an event. So we're configuring interesting things based on the time it takes them to happen. And we're doing that, we call that a sensitivity level. So we've set the sensitivity level to 100 milliseconds. Anything that takes longer than 100 milliseconds is typically considered interesting in this example. So stored procedures for one user taking over 100 milliseconds is...
So I guess my point is that this whole thing took 3 seconds.
Mm-hmm.
Procedure calls were only, less than half a second.
Yep.
So if there's 2.5 seconds somewhere else, probably the performance is not really equal.
Well, when you're looking at the context of something under 5 seconds, you're probably breaking it down that way, yes, because there's nothing else collected on the page. If you go look at, for example, the performance counters of this and look at this particular application, it's just now starting up. I've got no records of processing power and processing time, so this page is actually slow. The reality of it is it was just being requested for the first time, so it was going through the just-in-time compiling. Yeah. It's a very good question because that's exactly how you go through the process. That's another great use of the performance counters. Other things that we're looking at are those heaviest resources that are each one of those slowest nodes or heaviest components. So if I wanted to understand, for example, do I have SQL problems and what do those SQL problems actually look like? Better way of doing that would be to filter my events based on performance, because that's what I might be interested in, and then based on the heaviest resource. And again, I can sort these by the count, and I can see that my heaviest resource, 430 times, is this select statement. I can filter that even further. So I can go down and actually say all I want to see in that list, and that's what I'm doing, is filtering that list. All I want to see in the list is how many times SQL has impacted my performance. And I can see that I've got 14 individual records that SQL's the heaviest resource. Keep in mind, this SQL statement and this SQL statement could be happening on the same page, right? We're just looking at the heaviest resources here. So you can drill into an example incident. There's 434 times that one was slow. I'm going to look at one single example. So I drill into it and I can see the representation that this SQL statement took 1,400 milliseconds in that execution tree. And again, you get this individual event, you can say, well, okay, maybe one time that's okay, a couple of times that's okay, maybe you didn't come that way. Other things you want to look at might be correlating over the function that called that SQL. So that function the developer wrote was called get menu types. Every time it called that SQL and was slow was 22 times, and it averaged 2 seconds. Doesn't mean that in that example that we have to rewrite anything, or that we have to, you can simply categorize this event through the status that it's by design. It's going to happen all the time. We know that that SQL statement is a very large SQL call, or that stored procedure is doing a lot of work. But we've got the data now to go back out, do what we need to do to be able to profile it and understand what it looks like. Other things that we can actually do, and I forgot to do early on because I signed on as a user, is we can actually pull the user's information out so that when we have a support call specific to a user, we can filter the data based on that user. So I had logged in as user 1. So let me go ahead and filter for user 1 and look at everything that user 1 did in a certain time period. So I can see those 2 shopping cart failures that user 1 called and complained about. Some cases, user might not be the same for our applications. We might have tenant capabilities in our applications that, a large company comes in and uses this. So individual users aren't my concern, but the company is, or the tenant, right? So we can capture other data and filter on that, and we call that tenant filtering. So you would just simply create a tenant filter, tell us what the information is you want to pull out, what the variables are that's interesting, and we can filter on that as well. And that data all bubbles up. So one last incident that I'll actually walk through. I don't know if we typically show this in the examples. Everybody has probably seen AVIcode show you poor performance of a web page. I'm going to actually show you what takes place when a user receives a JavaScript failure and how that's collected. In this particular case, users experiencing sometimes some sort of slowness. They may be complaining, may not be complaining, but they try to make a purchase, simply go to the select statement. They don't know if something happened, something didn't happen. I don't know if you can really see it, but down in the bottom, they got a little warning saying that there was an error message. Some browsers will flash up a JavaScript error took place. Depends on how they're configured, how the user has configured their system. This one by default won't. And they might try that a couple of times. and not actually get to order any of those. So they go down and maybe, if they're patient enough, order something else and see that that took place. Now that, especially for food services, that could be pretty impactful, right? Because in this case, they're going to have Pear Brand muffins piling up and not being sold. And that's not good. So let's go back to see what's going on. If I go back and look in the SE Viewer, you see there's a couple of incidents that are categorized as fairly critical. They were categorized as being client issues because that's what took place in the browser. We're telling you what server responded to the request, what server created the HTML and sent it to that user. And then we're saying that that's actually an application failure, not a performance problem. If you go in and look at the detail, looks similar to other application failures, meaning there's a stack trace there, there's the context of the request, things like the session variables and the query strings are there. But here we're also going down into what were some of the parameters in the JavaScript at that moment in time. Fairly important because now I know that I'm having JavaScript failures, something to do with my Pear Brand muffins. And the price of the Pear Brand muffins they were trying to order is $10. So I got 2 failures, that's twice, that's $20 I lost. If you go up and look in the source of that, you'll see the actual JavaScript that was embedded into the HTML that allows them to add that. We're telling you what the failure was at the top. In the add item tells you that there was a percentage is undefined. Developers know what that means. They got a variable that they didn't instantiate in the top. The only thing they got is menu items. And there's the percentage that's undefined. And it happens to be for items that are $10 or greater. So I would never sell anything $10 or greater. They'd all stack up in the refrigerator. So very quickly we're gathering that data and details. Maybe it won't capture it all the time. It'll give you the parameters to recreate it and help you understand it. So if we don't get JavaScript because a particular browser is not allowing us to, that's fine. We'll give you the parameters to be able to recreate that, right? At a minimum, if you don't get the parameters, you will get the HTTP context, which again, helps you recreate that. Gives you a starting point, right? You can pull out of the session, depending on how you're storing sessions, maybe you can pull the session information out and recreate that. So it's beyond the alerting stage, beyond the triage stage, and you're down into the diagnostic stage, getting the information you need to do recreation of events, testing of the events after the fact. Once you say you fixed it, go into TFS, say you fixed it, upload it, it's running. You have the test capabilities to confirm it, right? Even the IT pros knew what took place, and they can go back and test it as well. So I think from a diagnostics point of view, I think that we have the information that we need to have to walk through those stages. But sometimes it's probably more important to understand in that larger picture, in that all the data that's coming in view. So let's have Chris come up and talk to us about what we do with all this extra information in a larger picture.
Okay, thanks, Sean. Any questions on what we just walked through before I jump into the reporting analysis? Yeah.
You walk through this sometimes, the JavaScript error comes up and slow. Are you getting performance from the client as well, like the page load time, stuff like that?
Yeah, I think that actually, that's still up. That wasn't covered. Good question. So the question is, can we also get, in addition to the JavaScript failures, can we get performance information at the client? So let me just run through that scenario quickly. Let's see here. Let's just do a little filtering. So absolutely, we can monitor for performance through that JavaScript injection that I've described. Let me walk you through an example here. Let me just find one. I'll just do a search by problem. And you can see here. So here's a good example. Let me zoom in. Which one is yours, Sean? There we go. Control 1. So here's you'll see client events are denoted by client page. And you'll see already just looking at the event, you can see search page slow at server response time. Meaning you already know before you even click into it that it's not even at the client, quite likely. And so let me show you what that actually looks like. So we'll open this up. So client-side events give you this view. And there's a lot of information in this view. So first and foremost, it gives you that total page response time. So in Sean's example of clicking through, we know that this user request took 3.7 seconds. Okay? Now, admittedly, for demo purposes, that might be quite low. If you go out and do reading on what is when do users start to get antsy if they think it should be quick, it's usually in the 8 to 10 second range. And oftentimes, those are good values if you're looking at production level values, and then you might drop that lower if you're in a QA test environment such as this. But maybe in the case of an e-commerce application, just like search engines, right, we want really fast performance, and maybe 3 seconds just simply is not appropriate for search. The important thing is understanding where the breakdown is, and so you get that in this view. So you're actually seeing that total duration broken down by how much time was spent in server execution. So you can see in this example, that's almost 87% of the time. You'll see network request time. Now, in our world, network request time is client time minus server time. So we're not doing network analysis in between. That's just a bucket of time. And there's other ways you can likely get at that. And then you also see at the time that the time to first byte, DOM loading time, and page ready time. So just as an example, in some cases, maybe you see really fast server-side response and lots of DOM loading time. Maybe you have an image problem. I've worked with customers, for example, that had a module in their application where the developers hadn't optimized their image sizes, right? So you had these 10 meg images that weren't all that important or big or whatever the scenario was coming down the pipe with every request. So if you see something like that where you think you have a load issue, there's a lot of additional information. As Sean was mentioning, we capture things like image size. So here we go. So here's images. And you can actually see a snapshot of what that image actually was being pulled down. Size of scripts. Seen examples where there's multiple scripting objects for the devs in the room, accidentally instantiated multiple scripting objects, and you're sending tons of duplicate script files down. Creates a bottleneck, right, when we're trying to load and process that on the client. So you get that kind of depth of analysis. And lastly, which I don't think this example will show because it does. He was authenticated. There we go. Let me zoom in. If you have authentication in your application, AD authentication, forms authentication, something to tag it back to a user, we can map it back to that. So we can actually see who is being affected here. The last comment I'll make on this is that if this page is executing a series of AJAX requests, which is quite common these days, right? You have page load, and then that page is executing AJAX requests asynchronously or even synchronously, even though that's probably not a great practice. We can correlate that together. We can capture asynchronous and synchronous requests being made by a page, because it may be, how many of us have gone to a page? Page came up quick, right? Going to some site, page came up quick, and the stock ticker takes forever to load. Just because the page came back didn't mean that was a good experience. And so, of course, you care about that. And so asynchronous AJAX requests actually, even though they get correlated to the page that spawned them, they will be captured separately because essentially they're separate requests. And you can do filtering and all the things that Sean took you through. Okay?
Forgive me if I missed it. You said using that jQuery injection I showed you earlier,
It's magical behind the scenes. So it happens on the server side. We actually didn't go through how that works, but the net result is the process of our end user monitoring results in putting JavaScript in at response time down to the end user. And it's that JavaScript that allows us to capture these performance metrics or when there's a JavaScript failure.
Did I have to put a server-side included?
You have to do absolutely nothing in your code. Okay, so this is all dynamic at runtime. This is all configuration based. Question?
Say you can search off a user for finding a problem. If it's numerous users hitting the same exception, but the user you're trying to investigate wasn't the first one in, are the others lost in the way that you can search on them, or do they get thrown away and you have to find the user?
Well, it all depends on how you're capturing the data, how you're aging out the data. But if there's multiple users having the problem and the data's there, then you can search on any of those users. Or you can, as Sean showed you some of those views, you look at all the similar events based on that problem and look at all the users, look at different instances of who was having that problem. Now, of course, if you have aging rules that age out that transactional information, it may go away at some point, which is, we're going to talk about reporting right now, how you can get a longer-term view of users. And actually, I hadn't planned on pulling up a user report, but I'm happy to do that. Question? We are not going to go through the install and config in this. Yep. Correct. Right. Unfortunately, we don't have time to go through that in this session. We had a session yesterday that went all through that, so we broke it up. This one just focusing on the output and the data. If you have the time, and I don't know if people are aware, we actually have a hands-on lab, one focused on install and config, and one's focused on walkthroughs like this in the hands-on lab. And even if you don't want to go through the full hands-on lab, you could just go pull it up, and there's a lab doc, and it probably is a good reference point just to give you a quick snapshot. Okay? All right, let's do this. Let's switch over and talk about reporting and analysis and get into some examples. And I'll go a little more quickly through this. So we have this reporting and analysis solution. It works off this transactional information. So we call it AVIcode Advisor. It siphons off the transactional information, puts it in a data warehouse format. We use SQL reporting services. The focus is to give us different lenses to analyze this information. So we may want to understand what are the predominant problem areas. So if I'm responsible, if I'm an application owner or a manager, and within my group, I own a series of applications, I need to understand the quality, the performance of my application over time. And I may want to have an understanding of, which applications are causing the biggest problems and where are those problems. Then we go down the layers. The application support team or development team may want to understand within my application where are the biggest chunks of problems. As Sean was saying, over the last release cycle of 30 days, what are the key problem areas that we're seeing? Or if we just put a new release out, what are the new problem areas that we're seeing? Right? IT may want to look and say, what's the variation over time? How is it impacting resources and how is it changing? All right? So these are the scenarios that we're getting at. So we have a series of reports. I won't get into this because we're going to walk through some examples right now. Let me switch over to my demo. Environment. And this was giving us issues earlier. Hold on. Okay. So let me introduce you to AVIcode Advisor. Just like you saw with the structured event viewer, we have a web-based console for the reporting and analysis piece. So when you install this, it actually you create your own SQL database. It installs a service that siphons transactional information off and puts it into this new database. So we use SQL reporting services. You can see a whole list of reports that we have here. I don't know the exact count, but there's a whole litany of reports. I'll just say up front, for those that actually get into this and say, you know, I'd really like to be able to run this type of report, this is all open. Actually, the user manuals have a breakdown of the schema of the database. So you can take these RDL files, or you can write directly to this data store and, you know, come up with your own reporting. So let me walk you through some reporting examples. One of the things, I'll just cover up front some of the capabilities that Advisor has. Like you would expect with any reporting solution, you have the ability to set up your reports. So you can see here, I've already set a series of favorites. So I'm going to run this client-side summary performance analysis. You can set these up and schedule these. You can put them out on a file share. You can send them out to a distribution list. There's some examples of reports I'm going to show you here where I think they're excellent candidates to, you have a distribution list between IT and dev, send out a status update on a regular basis so everyone can see what's going on. So let's start at the top. Let's start at the user endpoint. Let's start at, what if we want to understand performance at the client? How do we go about doing that? This is an example of how we might do this. So this is a summary performance analysis report, and let me talk you through how you interpret this, and I'll zoom in just a moment. So what we're doing is we're picking, so if we have multiple applications in our infrastructure that we're monitoring, I want to run this report across those applications that I'm monitoring and understand where the biggest problem areas are. So I have a stack rank. So you'll see 1 through 8. The first one on the list is the one with the biggest problems, and so on. And so this view at the top gives us a stack ranking. Now, how do you interpret this? I'll tell you that for those that put this in your environment and you have multiple applications and you run it, I'll bet that it comes out something like this, where you see this 3 out of 10 apps or something like that have the majority of problems that are being detected. In this example, you can see the 3 applications on the top represent 91% of the problems being reported in. Okay, so it already helps us narrow in on which ones are the most problematic. And we can see statistics about those applications here. But of course, we want to go further than that and understand within each application. So from a client perspective, you'll see we'll have a breakdown such as this. So what are the top, in this case, 5 slowest pages that our end users are experiencing? You can see that here. Now the question about the user report, let me run it a little differently. We can run a user report, and this keys off the user information that we're capturing. So if you install and configure the reporting piece, we can siphon that off and store that. And then we can do an analysis such as this to answer the question, who are the top impacted users, either across my applications, you know, if I have a portfolio I'm monitoring, or within. So you'll notice that we have NA, which would mean in this case that we have some application that has unauthenticated, and so that's a big bucket. You'll see the rest on the list are actual end users. And again, that stack ranking. But probably most importantly is, you know, here's my number 2 on the list, and here's the top 5 slowest pages by that user, just as an example. So, you know, if we're using this from a support standpoint, probably the better lens to put it in is per application, right? Within a given application, which users are having the worst problems with which sections of the app. And of course, you can't have reporting without process, right? So the key question is, how do you integrate this into this process? If support's using it, you know, maybe it's a part of a, you know, weekly review or monthly review or however to understand impact, and it gets passed back to the support team to investigate. A couple other examples, and I'll move a little more quickly because I kind of want to give you broad coverage so that you understand what you're able to do. We can break down the impact on the client side by groups. One group is, for example, by subnet. I worked with a banking customer. They had a banking application. It was actually a CRM application. And for any of us that have supported applications ever have this, certain geographies have problems and certain others don't. Ever had that? Okay. Well, in this case, that's what they had too. Every regional banking came back into the central data center. You know, they accessed the central data center for the CRM system. Their experiences were vastly different. They had different pipes, they had different networks, etc. How do you measure that? We could do that by, in this case, subnet. So we want to group by subnet, understand, again, this is just one example. You know, here's subnet number 1. What's the top slowest pages within an application or across an application? Okay. I'll go quickly through this because it's going to look very similar. That's a look at the client side. How about if we want to look at the server side? Same process. So you see this stack rank. You can see this first one, similar profile. 90.8% of the problems coming in are in these first 3 applications. This is quite valuable, really, for all the teams, right? Because it gives us that common understanding of say, okay, maybe there's some quick wins in here to improve quality. And I'd say almost every time I've worked with customers, we come to that conclusion. This, by the way, just as an aside, for those of you that are running off and decide that you're going to set this up in some type of QA environment or whatever it is, these problem analysis reports are ones that you can, you know, after a couple days or a week of running the solution, can run these reports and get some really actionable information that you can run back to teams with. Some of the other reports, like longer-term capacity trending reports that we'll look at, are a little harder to do until you get that length of time under your belt. But these are great ways to, you know, if you're going through a justification process, as an example, to say, hey, this is the type of information we can get. If this was a real live set of data and we had this number 1 application on the list, I can say to the application team, hey, look, the number 1 problem in this application that we're recording, which represents 45% of the failures being recorded for this application, is coming from the data access tier. And here's the individual occurrences of that. Because ultimately, right, it's back to this transactional data that Sean was walking us through. What are the guys that are going to make the changes going to need? They're going to need individual examples to troll through and understand why, right? Why do we have this particular issue? So that's an example of server-side performance analysis. And the same goes if you just want to further segment it by failure. So if we just want to look at failures, you know, again, what are the top 5 exceptions being thrown in the Jaggle info retrieval? So you can see very quickly this connectivity failure is 73% of the problems that we're having in this Jaggle info retrieval application. Okay? Helps us narrow down and focus. How do you use this? Well, we can use this as a management tool. We can use this as a change tool, right? What happens when you put a new release out? I'll show you some ways where you can measure what's the delta, what got better, what got worse. Or you can run this and compare it. What did we look before the release? What does it look like after the release? What new problems did we introduce? Gets us into this type of problem. I mentioned at the beginning there are cases where I think there's the type of reports that you can set up and send out to a distribution list. This is an example of what we call a status report, and I call it the finger in the wind, right? People take about 2 seconds on their BlackBerry or their mail to take a look and look and see if the pretty colors are changing direction, right? And if nothing looks different, then we move on. What are we looking at here? A snapshot of performance across a time period and reporting that back. So here's our Jaggle info retrieval, and here we can see across the time period. So I often encourage people, set this up to run and show you yesterday's performance, or maybe at the end of the week, whatever time period makes sense. and communicate it out to people who have a vested interest in this. So what are we seeing? We're seeing things like volume of events or problems, request count, load, request time, average request time for the application, in this case across a week. I'm running this weekly, right? And we're measuring it against a baseline. So what we can give you is how did yesterday compare to the previous day compared to a 90-day average. Again, the reason for that is just that are the levels varying, right? Is something off? Did we have a spike in events yesterday that we didn't see previously? Now, one of the interesting things in this report is you can actually see the delta. So you can actually see that we had 4 less performance problems than we did in the previous period. And you'll see this down this list, right? We had 180 less problems with this default page in this time period than the previous. Now, the cool thing here is, again, putting out new releases, naturally everyone's saying, are we getting better? Did we address some of the things that we put into play? You can actually run this report once you've got your new release out and use that to give you an indication. Like if you see, I don't know if I have an example here, but if we had 0 for number of events, and negative 180, we know that it's gone away, or it appears to have gone away. So we have a verification loop there. Okay, last few examples. Now I want to get into the trending and looking at more of the statistical information. And I think this is naturally something that the IT group tends to want to look at a bit more. So this is an example where we can look either by application or cross applications, and again, look at statistical information. Look at what's the volume of problems versus the request count versus average request time. Now, this may seem, these are all generated by AVIcode versus CPU and memory, etc. But let's think about how we can use this. I worked with a customer recently who said, okay, we're looking at implementing AVIcode. Okay, what's the application doing? Well, it's this internal application, and we've rolled it out to 400 users right now, and we're going to have it out to 1,000 users in the next couple of months. Now, that's over double the growth of the user. Naturally, the question is, behind the scenes, do we have the infrastructure to support it properly? So we can help use this as those users come on. We can trend this and understand, is average request time going up when the load is going up? And is that resulting in more problems or not? We can look at it in a variety of ways. As you see here, there's many different ways. We can even look at it by computer. So we can say, all right, for the computers in my server farm running this app, let's look at statistics by computer. One of the ways that might be helpful is if you think you're having a problem and you think it's a change management problem, maybe you have a server farm and something didn't get configured properly and one of those is going wonky on you, right, taking up more, this can start to give you insight and you can drill it all the way into the problems behind it. Let me switch back. I want to show you one last example. This is a real example. This is a real report. It's from the Xbox Live team. I can't actually tell you the date and time that this report was run. I will give you some hints that it was one of the biggest game launches. Again, I can't tell you what that might be. But you're actually looking at real data. Now, take a minute and see, because everyone's eyes are good visually at picking out trends, right? So take a second and see if you can spot the trends really quickly in this report. Maybe a couple seconds, then I'll talk about it. Okay, so like I said, you're looking at game launch. And one of the missions of the Xbox Live team was obviously putting together a launch plan for what they expected to be a highly popular game. You imagine there's a lot of infrastructure going behind it. Now, in doing so, the question on the table is, were we prepared? Were we successful in launching this game from an infrastructure perspective? Okay? Now, to give you some sense of scale here, you'll see that, well, let me just take you through it. Anyone catch kind of the trend on the orange line? Okay. So, launch Tuesdays are good days for launch days out in the software world, right? So, for those that have caught it, you see spike on Tuesday. Game launch day. Now, the top left event count, you can see that that really stays about consistent before and after. You can see the request count, just to give you a sense of scale if you can't see it in the back. We're up to about 14 million transactions an hour coming through this thing on that launch week. And that jumped from, 2 to 6. So we over doubled our typical usage. Take a look at request time. Pretty much flatline. Really no change. Now, CPU usage jumped. It doubled, but we're still 40%. And the team told me they run lean anyway, just as an intentional practice. So, of course, jumping to 40%, no big deal there. And, of course, as games kind of settle in, that tapers off. And then we have memory usage about the same, and I/O jumps up for a period of time. Now, this, of course, wasn't the only tool to answer the question of whether things were successful from a launch perspective, but you can see very succinctly how we can demonstrate that, yeah, from an infrastructure perspective, we handled the load, we didn't really change the problems being reported in, and the infrastructure handled it just fine. Okay? So this was considered by the infrastructure team to be a success. Okay? So we'll end on that. Any questions about the reporting or anything that we've covered today? Question?
Yeah, you showed the Advisor web application, but then on the SE Event Viewer web application, I noticed in the menu on the left there was an Advisor tab on the bottom.
Yep.
Is that just a link to the
Yep.
Advisor app? Or?
Yep, that's exactly right. Yeah, there's just a link over if you have an Advisor installed.
So if you didn't have Advisor installed, would it wouldn't do anything? Or
Right, that's correct. That's correct. Question?
Earlier, I think something was said about TFS. Can you tell me if any of these go into TFS?
Good question. So hopefully many of you saw the keynote where there's a CTP that was announced for an integration between Operations Manager and TFS. So essentially a OM to TFS connector. For the very purpose of that, being able to take operational events and push them over into a project. So what you'll get is, so Sean showed you we have events and we can roll them up into problem. So that same philosophy happens over in the work item on TFS. So you'll have a work item which represents a problem, and you have individual links to the incidences or events that make up that problem. So that's how that works. Sure. Question?
So one other question I have is that this looks like it's a great tool for helping developers pinpoint problems. But what happens if the problem, because I know sometimes I've written code where if the IT admins or the operations people change settings without coordinating with me, it can make my code behave very differently. So just for example, let's say they go in on a production server and alter a web config file without me knowing it. I can make my code behave very differently. Is AVIcode geared or going to be geared to kind of handle some of those outlying configuration changes that could cause code issues that it's capturing now?
That one, honestly, is very situational. I would say it really depends how the problem's manifesting itself, whether we're going to help you really quickly say that's a config problem in the web config, or it's going to help you get closer to thinking that there's an issue with the web config. I don't know, Sean, do you have any other
Yeah, I guess
thoughts on
for
that?
something like that, the typical scenario is you'll get exceptions thrown in your code that are out of the ordinary, things that put you into that diagnostics mode of why is this happening. Changes they might put into a web config file, I don't know, maybe changing the assemblies that your application relies on, updating something without your knowledge. that would throw exceptions because your code's not going to be looking or running that,
Yeah.
that assembly, right? So you'll have to reference that back. Will that tell you that they changed the web config? No, but that might give you a null reference error in your code that you didn't expect, and you'll have to...
I mean, as an example of
Does that
one
make
that
sense?
as an example of one that would, I saw that there was a production application where it had a bad path to image files, and it threw exceptions all over the place because it wasn't finding the image files. And so no one actually knew it was happening, right? It was a change management issue. Boom, we turned it on. Oh, easy fix, right? Config problem. So that's the type of thing that's kind of slam dunk. Okay, we're at the end, so I appreciate everyone's time. Would even more appreciate some feedback, so take a few minutes and give us some feedback. And we'll be around for a few more minutes afterwards if you have some further questions for us. Thanks, everyone. Have a good rest of the day.